What quantity of heat in kilojoules will be released if 1.15 moles of SrO is mixed with 0.923 moles of CO2 in the following chemical reaction? So here we are given first 1.15 moles of SrO. And if you look at the balanced chemical reaction, we have 1 mole of SrO. And the reaction, it says here the delta H is negative 241 kilojoules per mole. So just a reminder, the negative there only tells us the direction of the heat. The negative there only indicates that heat is being released by the reaction. So in other words, when it says negative 241 kilojoules of heat, it only means it releases 241 kilojoules of heat. So the magnitude of the heat is 241 kilojoules. So as you can see, the moles of SrO would cancel out. So basically, this is just 1.15 times 241, and this is 277.15 kilojoules of heat released. On the other hand, we are also given 0.923 moles of CO2. And if you look at the balance reaction, we have 1 mole of CO2. And the reaction releases 241 kilojoules. So the moles of CO2 would cancel out. So 0.923 multiplied to 241, that will be 222.443 kilojoules of heat released by the reaction. So between the two, 277.15 kilojoules and 222.443 kilojoules, which one is the answer to the question? So remember the concept of stoichiometry. So in stoichiometry, we learned about limiting reactant and theoretical yield, right? So that we apply the same concept here. So as you can see, 1.15 moles of SrO produces 277.15 kilojoules, and 0.923 moles of CO2 produced 222.443 kilojoules. So which one is the limiting reactant? Remember, the limiting reactant is the reactant that produces the smaller amount of product. So in this case, CO2 produces or releases the smaller amount of heat, which is 222.443 kilojoules. So the theoretical yield, or in this problem, if we relate it to this, the amount of heat released will be the smaller in magnitude. So the answer to this question is 222.443 kilojoules, or if you round it off, that's 222 kilojoules of heat released. So the answer to the question is 222 kilojoules.